Hello everyone, welcome to this new video lecture on Introduction to Computer Systems and Application. This course is designed to address computer systems and applications at introduction or introductory level. As I have said, the general goal of this course is just to address the basic and foundational understanding of computer systems, their components, operating systems, business data processing, data modeling, number systems, data management, data communications, data transmission modes, modulations, computer networks, and their applications. So in today's digital age, understanding computer system is essential for leveraging technology effectively in various fields. It could be from industry or business processes, from health industries, from any fields. It could be management aspect and other fields related to where computer systems is applicable and becomes crucial or vital. Having said that, the course will give emphasis on the foundational and fundamental aspects of computer system, such as number system, database management, data communication, data transmission models, the type of communication modes we have, the type of modulation, the type of data, analog, digital, computer networks, the type of computer networks we have, and the topology, their applications in detail will be addressed in this course. So, what is a computer system? To begin with the definition, a computer system is nothing else. It is an integrated set of hardware and software components designed to perform what specific task. So one can understand that a user or from the client side can enter a data, a raw data. What we mean by data in this case is a raw data, and then there is someone in between, which is according to the computer system architecture, which we call it a processor, will help us to process and transform this data into meaningful information, such that this output will be processed and transformed in such a way that could help and give insight for meaningful decision making process. So this computer system is very important concept to understand by the managerial and other business and other organization, of course, leaders. So having said that, the general architecture at high level, as we can see, there is an input, and in the middle there is a process. There is a processing. This processing can be represented by a certain component according to component of computer system, which is called the processor. The processor has a main unit, which is CPU. Then the CPU has different components, major three components, which we will discuss in its separate slide on the coming slide. But now at high level, what we mean by a computer system is nothing else. It is a transition from data into information and for meaningful decision making for the depending on the business context. And then we will have this output, and this output will will help us to have a meaningful decision process. So this also, this figure describes the high level of architecture of the computer system. As you can see, there are three components: the input devices, and the detail, what we mean by processing. There are three components: memory, and the ALU, which is the ALU means the arithmetic logic unit, which is responsible for arithmetic and logical units and other mathematical computations, which is a component of the processor, which we call it CPU. And the control unit is also in controlling or managing between these two components, the memory and the arithmetic logic unit. And finally, this, according to the CPU, once the task is processed and transformed, it has to go or flow or directly map into the output devices through different output devices, which we will be discussing in the coming slide. What we mean by output devices, their examples, practical examples, and similarly for input devices. So the memory unit also, the memory, there are two types of memory, in this case secondary and the main memory, or the primary, which is called RAM in this case. Okay, and there is another ROM, which is read-only memory, and this is random access memory. So this is also a general architecture for the computer system at high level. Having said that, the key components of a computer system, which we have mentioned above, are basically two, that is the hardware and the software. So this hardware is nothing else, the physical component of a computer system, which can be described as CPU, memory, input device, output device. We have said it, the input device are nothing else, where users could enter data or receive data through keyboard, mouse, and other things. And the output device are, after data are processed, then data could be displayed or presented or outputting data using monitor, printer, and other devices like speaker and headphones or earphones, for that matter. So the memory is where data has to be processed. We need a place where data could be processed and where data could be stored permanently. So that is the HDD, SSD, which is today's technology, supports SSD most laptops and PCs or whatever computers you can name. So for long-term data retention. So CPU, of course, as I have said, which is responsible for executing instructions and which is also the analogy of a brain of human being, which is a brain of the computer. So the second component is the software, which is also classified basically into two, which is system software and application software. So the application software are designed for specific tasks such as Microsoft Offices, word processors, spreadsheets, Excel, MS Excel, and MS Access, which managers mostly they use for database management system. And the system software is a critical component of the computer system, which is the named operating system, such as Windows, Mac operating system, Linux, and so forth. So depending on the type of the operating system we are running, that can manage hardware and provide a platform for the applications. So there are different architectures here, but it is beyond the course, of course. So the introduction can be summarized or recapped as evolution of computers. We will see those things. We will be discussing those things, a brief history of computers and characteristics, what is the basic features or major features, and classification of computers and their generations. What we mean by generations is nothing else the basic major advancement over time or through time. So this evolution of computers can be classified, or we have classified into three general paradigms just for our class lecture purpose, for clarity. So we have early mechanical devices, firstly digital computers, and modern computing advancements. So the modern computing advancements, which is about the AI and the machine learning, which is the today's technology, and the first digital computers, mostly the starting from the first generation of computers, second generation computers, third generation, and so forth. And the early mechanical devices can be perceived or analogically can be viewed to the abacus and the ENIAC, the first electronic numeral integrated computers. So having said that, the early mechanical computers, which is before this mid-90s, which is known for its introduction to the ABAX technology, which is the earliest tools for calculation used for basic arithmetic operations, and the Charles Babbage's analytical engine, which is also considered the first mechanical computer, feature concepts such as control unit and the memory. That is how during this time in mid-90s, almost in early 90s, this is how the computer evolution looks like. They are very large in size and costly, and of course not convenient. Okay, and in terms of speed, accuracy, and other things are also lower in quality. It's obviously one can understand it. So, following by the first generation of computers, there is now an advancement on the technology which uses vacuum tubes. That means the first electronic computers use the vacuum tubes for circuitry and magnetic drums for memory. Okay, so they were also, even in this first generation, are known for their large, expensive, and consumed massive amounts of power. This is highly disadvantaged and the characteristics of computers during that time, during that generation. So ENIAC is one known, developed in 1945. It was one of the first general purpose electronic computers capable of performing a wide range of applications. So this second generation, its technology, the underlying technology was transistors. That means replacing the vacuum tube of the first generation. So transistors made computers what? Smaller, faster, and more reliable. That's what human being we need. Smaller in size, faster, and more reliable. So there is a huge advancement in second generation. People have enjoyed during this time due to the underlying technology of the introduction of the transistors technology. So this generation was a development markedly known by introduction of COBOL and Fortran, which is high-level language by that time, which we are talking about the mid-90s and early 90s up to these days. Okay, then the IBM 1401 was a markedly used computer in business applications. It marked the beginning of the commercial computer industry. The third generation, which is the underlying technology for this, is the IC, integrated circuit, lead to even smaller and more powerful computers. And the major feature here is that improvement in processing speed and efficiency. So this is another characteristics of computers that we expect as a user. So the IBM system Series 60 launched in 1964, which was a groundbreaking system that allowed various applications to run on a single platform. That means multiple transistors are integrated into a single chip, which is the IC, integrated circuit. So the fourth generation is also known for its introduction underlying technology microprocessor, which is an advancement over the IC and transistors, of course. So the invention of this microprocessor marked a significant leap or forward or development, integrating thousands of transistors on a single chip. This is what it means, thousands of transistors in a single chip, like an advancement over the third generation. So this lead to a personal computer, that is a PC of today we have. So the fifth generation computers, which is the present and today, today or the present and beyond, which is markedly known for its AI and machine learning. Okay, so this is what it means. And another very, very important for our generation, which is the present and beyond, the introduction of quantum computing technology, which is an emerging field, of course, that promises to revolutionize computing by leveraging quantum mechanics concept for unprecedented processing power, which is unparalleled to compare even with the present technology or evolution of computers we have. This quantum is a little bit higher advanced. So the characteristics of computers, as we have seen in every generation, one can understand that we made comparison and advancement over these features: speed, accuracy, automation, storage capacity. So these are the parameters where, as a user, we expect an advancement or development over the evolutions or computer generations. So speed is one characteristic of computers. We expect high speed for processing a given instruction, which is unparalleled or uncomparable to the human task, because a computer can process millions of instructions or a set of instructions just in a per second or millisecond. Accuracy, obviously, for defined input, there is an exact output despite the error human being can make, which is not accountable to the computer's performance. Automation, in this case, repetitive tasks, can be automated and convenient for human use through the application of computers. So this is one characteristic of computers, can automate tasks, repetitive tasks. Storage capacity, still computers can give an amazing storage capacity which accommodates to billions teras bytes, which even evolves into the concept of the today's concept, which is a big data analytics. And versatility, computers are known for their versatile nature comparing to human, which is unimaginable characteristics. So the other concepts under this chapter is classification of computers. So one can understand the evolution and other characteristics. So we can classify computers by three things, at least by size, by purpose, and by process. So by size, we have micro, mini, mainframe computers, supercomputers. So these are personal computers for first ideal use. Example include desktop and laptops. Mini computers, mid-size computers that can serve multiple users simultaneously, often used in small to medium businesses or business organization. Mainframe, large and powerful, which is used by organizations for bulk data, for big data analysis and critical applications. And supercomputers, the fastest and most powerful computers used for complex competition simulations and scientific researches, especially at NASA. We expect supercomputers and other things. So the size increases down from generation to generation. So by purpose, there is general purpose computers and special purpose computers. So designed to perform a wide variety of tasks, PC laptops, and this built for specific embedded systems, gaming consoles. Unlike the general purpose computers, they are already designed critical mission based, okay, for specific tasks. Then by processing power, that is obviously there are analog, digital. These are the two types of data that we have in a computer system. The analog, it uses the continuous data and are typically used for simulation and modeling. Of course, this continuous data, what it means is that the data are continuously measured over time, just like signal. But to discuss beyond this concept is not really convenient, because that is beyond the content of the course in general. So digital computers also process discrete data, like the binary that we have said. The primary language of a computer system is a binary data, which is 0 and 1. Such things are called digital data. Then those computers process digital data are digital computers. So hybrid computers are computers that combine features of both analog and digital data in nature. So generations of computers in general, this is a kind of summary. So the first generation is known for its vacuum tubes technology. The second generation is known for its underlying technology, transistors. And the third generation is known for its underlying technology, integrated circuits. And the fourth generation is microprocessors. And this AI, machine learning, and quantum computing and robotics are the unique features or major features of generations of computer. So the components of computer system and computer memory, as we have said, the architecture consists of two components, just components of the computer system and components of the memory. Just there is an input device, then we have keyboard, mouse, scanner, joystick. And then the basic structure, like we have general component CPU. Under this CPU, there are three entities: control unit, ALU, memory, and then the output device, monitor, printer, speaker, and headphones. So what it means here is that, as I have said at the beginning, this control units controls every activity when the CPU do or does any activity or arithmetic logic unit. And on the memory. The memory is where data are being processed. Okay, the memory can be primary, and then there is register, cache. So it's no need, or it is beyond the course even, or beyond the mission of the course to go detail what cache, what register functionality. But in general, data need a memory to be processed and transformed and then changed into information, and this information will be displayed or outputted as data through the output devices like monitors, printers, speakers, and headphones in the form of signals, either analog or digital at the end of the day to the end user. So components of computer system, that's what we have said it briefly using the diagram. In the computer memory, these are the primary memory, the RAM, the secondary memory. This is what we have said it. So the number system is now here. It's very important thing. The data representation, the business management, people need to understand what data is and how data are collected, how data are analyzed, how data are can be turned into raw data, can be turned into meaningful and insightful for, and finally being used for an input for their effective decision-making process. So that's very interesting to know and important to know what number system. So computer understands binary digits, just 1 and 0. So this data representation refers how information is stored, processed, communicated within a computer system. So this is very important. How computers handle data is all about the numbering system. So this number system generally classified into 4, just binary, decimal, hexadecimal, and octal. So the binary is just a primary language, which is 0 and 1, and a group of bits forms byte, that's very clear. And then the decimal number system, which is the standard numbering system known by humans, and it has digits, which is some textbooks they call it Arabic numbers, 0 to 9 Arabic number, which is forms base 10. And the hexadecimal number system, which is base 16, which is the Arabic number from 0 to 9, plus from 10 to 15, which is the A up to F arrangement we have. So this represents the data. So it is often used in computing as a shorthand for binary. So whatever these are, another description or equivalence, otherwise computer still understands the binary format. Then octal, which is a base 8, that constitutes from 0 to 7. It is less commonly used but can simplify binary representation, octal. So understanding this number system is essential for tasks such as programming, data encoding, and computer networking in general. So the number system is basically 4. So here is the diagram. We have decimal, base 10, base 2, which is binary, base 8, which is octal, base 16, which is the hexadecimal. So one can understand this is 0 to 15 means 16 for in total. That the binary, for example, using 4 bits, you can have 0, 0 by 0 for 1, 0, and then this is 0. So if you multiply this by 2, then you can get the equivalence. So the octal numbers represent us from 0 to 7, and the hexadecimal from 0 to 15 for this one, for this equivalence, which is 0 to 9, then A to F. Then the octal 0 to 7, just they can represent up to this. And the binary for this one, just we have using 2 bits, then they can represent that one. So you can see here the ASCII code character to binary. Obviously, the characters, even the ABCD and other things have their own equivalence using different formats. So, for example, this is a decimal number 243 to this one. Then it is easy to do it like this one, you divide by 2, this one you divide by 2. Then finally, you put in ascending, in descending order. That means from top to from bottom to up. That means 1 1 1 1 1 0 0 0 1 1. So you divide by 2, or just simply you can multiply this from 0 this as a base 2, simply like base 10, what we call it base 10 here, 0 tens and hundreds, then 0 ones and tens, like that, 0 1 2 3 4 5 6 7. So to the power of 7, 1 times to the power of 7 plus then 0 0 0, then finally you can get, for example, this is 1 to the power of 0 means 1 times to the power of 0, which is to the power of 0 is 1. 1 times 1 is 1. So this is 1. So you can add up these things, then 2, 4, 3, simply. So this is the summary number system. Then this is a base. Then this is a unit digit. And this is just the extra examples that students to try out. So what I want to say here is that in this section, students are expected to check and verify using different examples for this 4 major computer number system representation to exercise on these things. And then this is the last section of this chapter, review questions. So these questions are prepared for the students to understand by their own pace. Unless they face some challenges, they can forward to the instructor. Thank you very much.